Fourier's theorem. Fourier's theorem states that any single valued periodic function, this is a single valued periodic function, it can be expressed as a summation of sine and cosine terms. So it is expressed as sine and cosine terms along with a constant DC level. So this is the DC level and these are known as Fourier coefficients. A0, an and bn are the Fourier coefficients. Okay, so if ft is a periodic function having period capital T, then the Fourier series is ft is equals to a0 by 2 plus summation n equals to 1 up to infinity an cos n omega t plus summation n equals to 1 to infinity bn sin n omega t. This is the periodic function and it can be expressed as this. Now let's evaluate the coefficients an and bn and a0. First of all, let's integrate equation 1. So let's take the integration 0 to t f of t dt is equals integration 0 to t a0 by 2 dt plus we can take the summation outside, so n equals to 1 to infinity and an can be taken outside, so it will be 0 to t cos n omega t dt plus n equals to 1 to infinity bn 0 to t sine n omega t dt. Now we know that from integration that 0 to t is cos n omega t dt is 0 and also 0 to t sine n omega t dt is 0. So we are left with a0 by 2 integration dt is t and 0 to t f of t dt. So we get these are all 0. So we get a0 is equals to 2 by t integration 0 to t f of t dt. So this is the first coefficient, that is a0 equals to 2 by t 0 to t f of t dt. Now let's multiply equation 1 by cos m omega t dt and then integrate from 0 to capital T. So multiplying equation 1 by cos m omega t dt and then taking integration. So in the left hand side it will be 0 to t f of t cos m omega t dt and in the right hand side it will be a0 by 2 integration 0 to t cos m omega t dt plus summation n equals to 1 up to infinity and an integration 0 to t cos n omega t multiplied with cos m omega t dt, cos m omega t dt plus summation n equals to 1 up to infinity bn sine integration 0 to t sine n omega t multiplied with cos m omega t dt. Now 0 to t is cos m omega t dt is 0. In a full cycle cos m omega t dt is 0 and we also know that sine n omega t multiplied with cos m omega t dt in full cycle is also 0. So we are left with now this integration can only exist when n and m are equal, then this integration will give us t by 2. Otherwise this integration will be 0 if m is not equals to n. So for m equals to n, so our an will be a m and the whole integration will give us t by 2, right? So we can find a m is equals 2 by t integration 0 to t f of t cos m omega t dt, right? This is for m, so we can write it also for n. So this is our second coefficient. Similarly, if we multiply the first equation with sine m omega t dt, similarly if we do the same and multiply the equation 1 with now sine m omega t dt, then we will get our second coefficient, that is Bn, that will be 2 by t 0 to t f of t sine n omega t dt. So this is our second coefficient.